Welcome back, everybody, to the deep dive. Today we are diving into something that's pretty essential to our digital lives, but honestly, most of us probably don't think about it very much. Database testing.
Yeah, for sure.
And when you really consider it, everything from, banking and online shopping to healthcare records and even like, that game you play on your phone, it all relies on these databases working behind the scenes.
Mm.
And we're really lucky today to have a true expert with us who's going to guide us through this. We're using the database testing tutorial.pdf as our main source material. And I think it's going to be a fascinating deep dive. So maybe before we get too far, can you just give us a sense of like why database testing even matters? Like why should we care about this?
Well, think about it this way. A tiny glitch, like a really small glitch in a database, can end up impacting like millions of users, right?
Yeah.
It's crazy.
Oh, yeah.
I mean, just think about all the times you've seen like a website crash during a sale.
Yeah.
Fans are trying to buy tickets and the whole thing just goes down.
Yeah. That's often because they didn't do proper database testing, specifically load testing.
Right, right. It's like the whole system is only as strong as its weakest link, right? And often it's the database that's that weak link.
Exactly.
Okay, so we know it's important, but maybe like what exactly IS database testing? Like how would you define it for someone who's totally new to this concept?
So it's basically making sure that all the data stored in a database is accurate, reliable, and secure.
Okay, so it's kind of like triple checking everything, making sure it's all good.
Yeah. And it's not just about the data itself.
Right.
It's about the whole ecosystem around it, like the schema, tables, triggers, stored procedures, like everything that makes it all work.
Oh, okay.
It's like, if you're building a house, you wouldn't just check that like the furniture looks nice.
Right.
You'd want to make sure the foundation is solid, walls are strong, the wiring's done right.
Gotcha. Okay, so it's like the whole package, like the whole infrastructure of the data.
Exactly. Exactly. So I'm kind of curious, like, how is that different from the kind of testing we experience as users? Like, when an app, let's say, says they've fixed bugs, is that database testing or is that something else?
That's a good question. So that's more likely like user interface testing.
UI testing.
Yeah, UI testing, which focuses on the front end, what the user actually sees.
Right.
Database testing, though, digs into the back end. It's the engine driving it all.
Okay.
It's like, think of a play. UI testing is making sure the actors hit their marks and the set looks good, right?
Right.
Database testing is making sure that the stage is stable, the lights work, and the sound system doesn't, like, blow out in the middle of the show.
Got it. Okay. So one's kind of like the performance we see and the other one's the behind the scenes mechanics that make it possible.
Exactly.
Okay. That makes total sense.
Hmm.
Now, our source breaks down database testing into three main types, right? There's structural, functional, and non-functional. So I guess let's start with structural testing. What exactly are we looking at there?
So structural testing is like examining the blueprint of your database.
Mm.
It's like if you're an architect and you're, checking the plans for a skyscraper.
Right.
You want to make sure the columns are strong enough to support the weight, beams are connected, or, all that stuff.
Right, right. So it's like the nitty-gritty of how it's all structured.
Yeah, and in database terms, this is schema testing. We're making sure the tables and columns are designed right, data types are all compatible, relationships between the tables are clear. It's a lot of detail.
Yeah. And it sounds like, this is where SQL mastery becomes really important, right? Not just knowing the language, but knowing how to use it to really scrutinize the database structure.
Oh, absolutely, yeah. Like just a simple SQL query, you can check if data types and related columns actually match. And
Oh.
like a mismatch, like storing a product price as text instead of a number, that could cause like huge problems.
Yeah. Yeah, that makes sense. Like it's those seemingly small details that can like snowball into these major issues if you don't catch them early on.
Oh yeah, for sure.
Okay, so structural testing is about making sure that foundation is rock solid before we even start like putting any data into the house.
That's like so.
Okay, but then we need to make sure the house actually functions as intended, right? Like that's what functional testing comes in, I assume.
Yeah, you got it. Functional testing is all about checking if the database actually does its job the way it's supposed to.
Okay.
Like, does it process data accurately?
Mhm.
Can users log in securely? All that stuff.
So it's almost like from the user's perspective.
Exactly, yeah.
Yeah.
It's about making sure the database behaves as expected from the end user's point of view.
Okay. Okay, that makes sense.
Like, let's say you're building a banking app, right?
Right.
A big part of functional testing would be verifying that transactions are processed right, balances update correctly, and user accounts are actually protected.
Yeah.
You know,
Right, because any errors there could be like massive like financial repercussions.
yeah, absolutely.
So it's really high stakes. Okay,
Yeah.
so using our house analogy again, it's like we've built the structure, now we're making sure like the plumbing works, the lights switch on, the doors lock, you know.
Exactly. Yeah, we're not just admiring the architecture, we're making sure it's actually livable.
Right, right. That makes perfect sense. Okay, so we've built a structurally sound database. We've confirmed it functions properly. Um, I guess what else could there possibly be?
Well, these days, it's not enough for a database to just work.
Right.
It needs to work well, like under pressure.
Right, like real world conditions.
Yeah, exactly. And that's where non-functional testing comes in.
Right.
This focuses on things like, performance, scalability, security, reliability,
Right.
basically making sure your database can handle the real world.
Okay, yeah. That makes sense. Like we've all experienced, I'm sure, like a website crashing during a big sale or like an app freezing up when you need it most. It's
Exactly.
like the worst possible time.
Yeah, and non-functional testing helps prevent those kinds of things from happening.
Okay.
Like one key area here is load testing.
Uh-huh.
We simulate like high user traffic, tons of users, and we see how the database responds.
Yeah.
Can it handle hundreds or even thousands of users accessing data all at the same time without like slowing down or crashing?
Right, right. So it's almost like a stress test for your database.
Yeah, exactly.
Okay, okay. So are there other types of non-functional testing too that we should kind of be aware of?
Yeah, yeah. There's a whole bunch like stress testing.
Okay.
This one pushes the system even further, like trying to actually find its breaking point,
Wow.
like figuring out how much weight a bridge can hold before it collapses,
Okay.
that kind of thing.
That sounds pretty intense.
It is.
But I guess it's better to find those weaknesses in like a controlled test environment than in, a real world situation.
Exactly, yeah. Much better to find it then.
Okay. So stress testing, what else is there?
Then there's security testing. This one is like critical these days with all the, cyber threats and everything.
Oh, yeah.
And this involves like trying to penetrate the database's defenses,
Oh,
identifying vulnerabilities, making sure the data is protected from unauthorized access.
so it's like you're almost hiring an ethical hacker to try to break into your system so you can see where the weak points are.
Exactly. Yeah, you want to find them before the bad guys do.
Oh, okay. Okay.
And security testing is all about making sure that your database is like a fortress, not a sieve.
Right, right. Makes sense.
And then there's reliability testing, which focuses on the database's ability to like perform consistently over time, even when like unexpected things happen, like power outages or hardware failures, stuff like that.
So it can withstand like a little bit of chaos.
Exactly, yeah. It needs to be resilient.
Okay, okay. So if structural testing is about the blueprint and functional testing is about making sure everything works, then non-functional testing is like making sure it's built to survive an earthquake.
Yeah, I like that.
That's a good analogy.
It's about making sure your database is like robust and resilient and ready for whatever the world throws at it.
Okay, okay. I'm starting to get a much better sense of all this. But I am curious, what are some common misconceptions about database testing? Like, is it just, a bunch of tedious tasks that slow down the development process?
Yeah, that's a common one.
Okay.
But it's really not true. Database testing, yeah, it takes time and effort, but it's an investment.
Okay.
Like you're investing in the long-term health of your application.
Right, right. Because if you catch the issues early, it's going to save you headaches down the road.
Exactly.
Okay, so it's kind of like going to the dentist for regular checkups.
Yeah, exactly.
It might seem like a hassle, but it can save you from like painful and expensive procedures later on.
Exactly. And another misconception is that it's like too complex for most developers to handle.
Right, right.
But, it does require some specialized skills, but there are tools and resources that make it a lot easier these days.
Okay. Okay. So it's becoming more accessible.
Definitely.
That's good to know. So what are some best practices then that developers and even like, non-technical folks should keep in mind when it comes to database testing?
Well, one of the most important ones is to start testing early.
Okay.
Like, don't wait till the end of the development cycle to start thinking about this.
Right.
Integrate it into your workflow from the beginning.
So it's not a one-time event. It's like a constant process.
Exactly.
Yeah.
Another important one is to validate both the metadata and the functional data.
Okay, I'm not sure I follow. Can you kind of break that down a bit?
Sure. So metadata it's basically data about the data.
Okay.
So validating that involves checking things like, column names, data types, constraints,
Yeah.
making sure the structure aligns with the requirements.
Yeah.
And then functional data validation ensures that the actual content of the database is accurate and consistent.
Okay. So it's like checking the labels on your spice jars in your kitchen, to make sure they're accurate, and then also actually tasting the spices to make sure they haven't gone stale.
Yeah, I like that. That's a good way to put it.
Okay, so metadata and functional data. What else is there?
Another best practice is to use a combination of manual and automated testing.
Okay. Why not just automate everything?
Well, automation is great for like repetitive tasks and covering a wide range of scenarios,
Yeah.
but manual testing lets you do more exploratory testing.
Okay.
Like you can use human intuition to uncover issues that automated tests might miss. It's like, having a detective and a forensic scientist working together on a case.
Okay, yeah.
The detective brings like human insight and experience, and the scientist provides data-driven analysis.
Right. It's like you need both perspectives to get the full picture.
Exactly.
Okay.
Combining both approaches gives you a much more comprehensive testing strategy.
Got it.
And finally, it's really important to prioritize data integrity and referential integrity.
Okay, remind us what those are again.
Yeah, so data integrity ensures that the data in the database is accurate and consistent,
Okay.
like checking for null values, duplicate records, invalid data types, stuff like that.
Right.
And referential integrity focuses on maintaining the relationships between tables, making sure those foreign keys correctly link to primary keys.
Right. So like using our university database example again, like referential integrity would make sure that you can't enroll a student in a course that doesn't exist.
Exactly, yeah.
Or assign a grade to a student who's not even enrolled in the class.
Yeah, that's a good example.
Okay, good.
And maintaining these integrities, it makes sure that the database remains consistent and reliable, even when changes are made.
Got it. Okay, so it's all about kind of like keeping everything in check, making sure that the relationships are all valid.
Exactly.
Okay, wow, we've covered so much ground today.
Yeah, we have.
Like from the three main types of database testing, structural, functional, non-functional, to like best practices and common misconceptions.
It's a lot to take in.
Yeah, it really is. And it's amazing to me how much we rely on databases without even realizing it.
Yeah, for sure.
Like we've talked about, finance and e-commerce, but what other areas do you think could kind of benefit from more rigorous testing?
Oh, man, like so many.
Yeah.
Like think about healthcare records.
Oh, yeah.
The accuracy and security of those databases, that's like critical.
Yeah.
Any errors or breaches there could have like life-altering consequences.
That's a really sobering thought. And what about like with the increasing reliance on data in fields like transportation, urban planning, all that?
Oh, absolutely.
Like smart cities, all that.
Yeah, like smart cities rely on these huge interconnected databases,
Yeah.
to manage everything from traffic flow to energy consumption.
Right.
Like a single glitch in those systems could cause like massive chaos.
Yeah. It really highlights how crucial database testing is, not just for like individual applications, but for like the infrastructure of our society almost.
Yeah, for sure.
It's like we trust these systems to work flawlessly, but how can we like as users even like advocate for more robust testing practices?
That's a good question. One way is to just be more aware of like the role of data in our lives.
Yeah, right.
And demand more transparency from companies about how they're handling our data.
Right, like asking those tough questions.
Exactly.
Okay.
We can also support developers who like prioritize testing. Look for companies that have a good track record.
Right, so it's kind of like choosing a car based on its safety rating.
Exactly.
You want to know that the systems that you're relying on have been thoroughly vetted.
Exactly.
Okay. So awareness, transparency, and really just kind of supporting those who are doing it right.
Yeah, and staying informed,
Right.
The more we know, the better choices we can make.
That's a great point. This has been a really eye-opening deep dive into the world of database testing.
Yeah, it has.
It might seem like a behind-the-scenes technical detail, but it has like huge implications for all of us.
Oh, for sure.
Like it really does.
And it's a good reminder that even in our digital world, the reliability of these systems we depend on, it really comes down to human diligence and expertise.
That's a really good point. So the next time you're, using an app, making a purchase online, or even just checking the weather forecast, take a moment to appreciate the unsung heroes of database testing.
Mm.
The ones who are working behind the scenes to keep our digital world running smoothly.
Yeah, they are the guardians of data integrity.
They really are.
For sure.
Well, thanks for joining us on this deep dive.
Yeah, thanks for having me.
We hope you learned something new today
Me too.
and gained a new appreciation for this really crucial role of database testing.
Definitely.
So until next time, keep exploring, keep learning, and keep those databases clean.
Yeah, keep them clean.
Okay, so we've built this structurally sound database, and we confirmed that it functions properly. What else could there be?
Well, in today's world, it's not enough for a database to just work.
Yeah. Okay.
It needs to work well under pressure.
Okay.
And that's where non-functional testing comes in.
Right.
It focuses on things like performance, scalability, security, reliability.
Yeah, those are pretty important.
Yeah, essential, really, making sure the database can actually handle the real world.
Okay, yeah, that makes sense. Like, we've all experienced the frustration of a website crashing during a big sale,
Oh, yeah,
or an app freezing up when you need it most.
exactly. And non-functional testing helps prevent those scenarios.
Yeah.
One key area here is load testing. We simulate high user traffic to see how the database responds. Can it handle hundreds or even thousands of users all at once?
It's like a stress test.
Yeah, like a stress test for your database.
Yeah.
Making sure it can handle like a Black Friday rush without, buckling under pressure.
Right. That makes sense. What are some other types of non-functional testing we should know about?
Well, there's stress testing, which pushes the system even further, like trying to find its breaking point.
Okay.
It's like figuring out how much weight a bridge can hold before it collapses.
Okay, so you're really trying to break it in the testing environment.
Yeah, better to find those weaknesses there than in a real-world situation.
Absolutely, yeah.
Okay, so stress testing, what else?
Then there's security testing, which is crucial these days with all the cyber threats. Oh, yeah, for sure.
This involves trying to, penetrate the database's defenses,
Okay.
identifying vulnerabilities and making sure sensitive data is protected.
So it's almost like having an ethical hacker try to break into your system to expose any weak points before the bad guys can.
Exactly. You want to find those weak points before the bad guys do. Security testing aims to ensure that your database is a fortress, not a sieve.
Right. That makes sense. Okay, load testing, stress testing, security testing.
And then there's reliability testing,
Okay.
which focuses on the database's ability to perform consistently over time, even when unexpected things happen,
Okay.
like power outages or hardware failures.
Okay, so it can withstand a little bit of chaos.
Exactly. It needs to be resilient.
Okay. So if structural testing is about the blueprint, functional testing is about making sure everything works, then non-functional testing is like making sure it's built to survive an earthquake.
That's a great analogy.
Yeah.
It's about ensuring your database is robust, resilient, and ready for anything the real world throws at it.
Perfect. This is all incredibly insightful, but I am curious, what are some common misconceptions about database testing? Is it just a bunch of tedious tasks that slow down the development process?
That's a common one, yeah.
Yeah.
But it's actually quite the opposite.
Okay.
Database testing does require time and effort, but it's an investment in the long-term health and success of your application. By catching and fixing these issues early on, you prevent them from becoming much bigger and more expensive problems down the line.
Right. It's like going to the dentist for regular checkups.
Yeah, exactly.
Might seem like a hassle, but it can save you from really painful and costly procedures later on.
Exactly. And another misconception is that database testing is too complex for most developers to handle.
Okay.
While it does require specialized skills, there are tools and resources that can simplify the process and make it much more accessible.
Oh, that's good to know. So it's becoming more and more accessible over time. So what are some best practices that developers and even non-technical folks should keep in mind when it comes to database testing?
Well, one key best practice is to start testing early and often. Don't wait until the end of the development cycle.
Okay.
Integrate it into your workflow from the very beginning.
So it's not a one-time event.
Right. It's an ongoing process throughout the entire development lifecycle. Another important best practice is to validate both the metadata and the functional data.
Okay, I'm not sure I follow. Can you break that down a bit?
Sure. So validating metadata involves checking things like column names, data types, and constraints,
Mm-hmm.
all to ensure the database structure aligns with the requirement.
Okay, so the basic structure.
Yeah, and then functional data validation. That ensures the actual content of the database is accurate and consistent.
So it's like checking the labels on the spice jars in your kitchen to make sure they're accurate, and then actually tasting the spices to make sure they haven't gone stale.
That's a great way to put it.
Okay, so metadata and functional data. What else?
Another important best practice is to use a combination of manual and automated testing techniques.
Okay, why not just automate everything?
Well, automation is great for repetitive tasks and covering a wide range of scenarios, but manual testing allows for more, like exploratory testing and human intuition, to uncover issues that automated tests might miss.
Okay. Yeah,
It's like having a detective and a forensic scientist working together on a case.
right.
The detective brings human insight and experience, while the scientist provides data-driven analysis.
So you need both to get the full picture.
Exactly. Combining both approaches gives you a much more comprehensive and robust testing strategy. And finally, it's crucial to prioritize data integrity and referential integrity throughout the testing process.
Okay, and remind us again what those mean.
Yeah, so data integrity ensures that the data in the database is accurate and consistent. For example, checking for null values, duplicate records, and invalid data types. And referential integrity, that focuses on maintaining the relationships between tables, ensuring that foreign keys correctly link to primary keys.
So using our university database example again, referential integrity would ensure that you can't enroll a student in a course that doesn't exist or assign a grade to a student who's not enrolled in the class.
Exactly. Maintaining these integrities ensures that the database remains consistent and reliable even when changes are made.
Wow, we've covered so much ground today.
We have.
From the three main types of database testing, structural, functional, and non-functional, to best practices and common misconceptions. It's amazing how much we rely on databases without even realizing it.
Yeah, for sure.
We've talked about the importance of database testing in, finance and e-commerce, but what other areas do you think could benefit from like really rigorous testing?
Oh man, there's so many. Think about healthcare records.
Oh, yeah.
Like the accuracy and security of those databases are just absolutely crucial. Any errors or breaches there could have life-altering consequences.
Yeah, that's a really sobering thought. What about with the increasing reliance on data in fields like transportation and urban planning?
Oh, absolutely. Yeah, like smart cities, right?
Yeah, smart cities.
They rely on these massive interconnected databases to manage everything from
Yeah.
traffic flow to energy consumption.
Right, right.
And a single glitch in those systems
Mhm.
could cause just widespread chaos and disruption.
Yeah, it really highlights how crucial database testing is, not just for individual applications, but for the infrastructure of our society.
Yes, sure.
It's like we trust these systems to work flawlessly, but how can we as users even advocate for more robust testing practices?
That's a really good question. One way is just to be more aware.
Okay.
Just be more aware of the role of data in our lives.
Right.
And demand more transparency from the companies that we use about how they're handling our data.
Right.
Yep.
Right. Yeah, like asking those tough questions.
Exactly, yeah.
Uh,
We can also support developers who, make testing a priority.
Hmm.
Look for companies that have a good track record when it comes to data security and reliability.
so it's kind of like choosing a car based on its safety rating.
Exactly.
You want to know that the systems you're relying on have been thoroughly vetted.
Exactly.
Okay. So awareness, transparency, and supporting those who are, doing it right.
Yeah. And staying informed.
Right.
The more we know, the better choices we can make.
That's a great point. Well, this has been a really eye-opening deep dive into the world of database testing.
Yeah, it has.
It might seem like a behind-the-scenes technical detail, but it really has huge implications for all of us.
Oh, for sure. Yeah. It's a good reminder that even in our increasingly digital world, the reliability of the systems we depend on, it really comes down to human diligence and expertise.
Yeah, that's a really good point. So the next time you're, using an app, making a purchase online, or even just checking the weather forecast, take a moment to appreciate the the unsung heroes of database testing,
Yeah.
the ones who are working tirelessly behind the scenes to keep our digital world running smoothly and securely.
Yeah, they really are the guardians of data integrity.
They really are. Well, thanks for joining us on this deep dive.
Yeah, thanks for having me. This was fun.
We hope you learned something new and gained a new appreciation for the crucial role of database testing. So until next time, keep exploring, keep learning, and keep those databases clean.
Yeah, keep them clean.